partial derivatives, we talk about partial derivatives whenever there is a function of more than one variable. Suppose z is a function of f x comma y, then if we are differentiating z with respect to x, suppose del z over del x and del z over del y, that means we are differentiating z partially with respect to x or with respect to y, keeping other variable as constant. Keeping other variable constant is called partial derivative. Constant. Okay. So if we want to compute its mathematical form, mathematical definition of partial derivative, like del z over del x equal to del f over del x. It is limit delta x tending to 0 f of x plus delta x y minus f of x comma y upon delta x. It is delta x upon delta x. Delta x is tending to 0. So we will say partial derivative of the function z is this value. But the thing is what? It will be partial derivative whenever limit exists. Okay. Similarly, we can write the partial derivative with respect to y. Del f over del y, and del f over del y, that means the rate of change of f with respect to y. That means limit delta y tending to 0, x is constant and y is varying, y plus delta y minus f of x comma y upon delta y. Okay. So del f over del x, we are also represented by fx and fy. These are the derivative of f with respect to x and y. Okay. Next is when we'll say partial derivative exists whenever these limit exist. Okay. Now let's do one example. Find the value. Example. Find the value of del f over del x and del f over del y at the point x comma y of the function fxy equal to y e raised to power minus x by definition. Okay. Definition. So what we have to do, we have to compute the value of del f over del x, del f over del y at some point xy of this function y equal to e raised to power minus x. Okay, f is equal to what? That is, I should write f x comma y equal to y e raised to power minus x. If we are computing it directly with respect to derivative of f with respect to x, del f over del x, that means we are keeping y constant. So let's differentiate it. Y is constant, so y will remain as it is. Differentiation of e raised to power minus x, e raised to power minus x into minus 1. Differentiation of minus x is minus 1. That is y e raised to power minus 1. If we are computing f of y, then x is constant, here y is constant. Okay. And when we are computing del f over del y, that means y is constant, e raised to power minus x. Here y is del f over del y, that means x is constant and we are computing differentiation of y is 1. And e raised to power minus x is what? That is constant. Why? Because whenever, as per the definition, del z over del x, del z over del y is the partial derivative of the function x of z with respect to x and y, keeping other variable constant. Okay. So this is the value of fx and fy. Now let's compute function like del f over del x by definition. Del f over del x by definition. Okay. So let's write it. Now, del f over del x, it is by definition. Limit delta x tending to 0 f of definition क्या है, x plus delta x comma y minus f of x comma y upon delta x. ठीक है, तो लिमिट delta x is tending to 0. Here what is the value of fxy? Y e raised to minus x. Y e raised to minus x. But x is what now? X plus delta x. So x plus delta x, y as it is, minus y e raised to minus x upon delta x. Okay. Now limit delta x tending to 0, y e raised to minus x, e raised to minus delta x, minus y e raised to minus x, delta x. Y e raised to minus x can be taken as common. Here you are getting e raised to minus delta x minus 1 upon delta x. Okay. Now y e raised to minus x outside and limit delta x is tending to 0, e raised to minus delta x minus 1 upon delta x. So what is the limit of this function? So it is 0 by 0 form. If we are taking this limit, then we can apply L'Hopital rule. So y e raised to minus x, so differentiation of e raised to minus delta x minus e raised to minus delta x. Okay, and differentiation of minus 1 is 0 upon 1. So and limit delta x is tending to 0, y e raised to minus x, and limit of this is what? Minus 1. So y e raised to minus x. This is the value of del f over del x. It is same as we computed here. Okay. So similarly we can compute the value of del f over del y. Del f over del y. It is what? Limit delta y tending to 0 f of x plus delta y, sorry, x comma, there is a change in y plus delta y minus f of x comma y upon delta y. ठीक है, so x y plus delta y minus f x y upon delta y. So what is the function? Y e raised to y plus delta y e raised to minus x, because the function is, because f is equal to what? That is y e raised to minus x minus y e raised to minus x. So what is coming out to be? Lambda delta y is tending to 0, delta y e raised to minus x upon delta y. It is coming out to be e raised to minus x, because delta y is getting cancelled. So del over del y that we computed by definition, it is same as from here we got. Okay, so this is called partial derivatives. Okay, next let's do one more question.